group discussion. Have done. Sorry. So we have done the this physical portion, we have done it. Then chemical properties also we started. Then we'll see the reactivity with we'll try to see their reactivities. Okay. So now we'll go for a reactivity.
We cannot see the board properly, sir.
So nicely you told me I have to do something. Ah, can you see now?
Yes, sir.
Reactivity towards hydrogen. That is, here we are going to discuss the reactivity of all the elements of group 15. Okay. So we'll write now here. Group 15 element. Acha, did I send you this note of group 15? Sorry. Did I send you the P block note?
No, sir.
Ah, very good. Then you do one thing. You can also request Sir Somnath, because all my notes are in his computer. Okay. So let him post it in your group. Then all of you can see, and from there I can also copy. Huh? All right. So send a request to them. Sir, please, Sir Majumdar told us, please post that P block notes. Question answer now you not required. Question answer will send later on. Let us finish, then question answer will put. Let him send a note. Because such a big note I cannot save it in my mobile. Group 15 elements react with hydrogen to form. Any request you can make it to Sir Majumdar. Sir Majumdar he is also Majumdar. I am also S Majumdar. He is also S Majumdar. You can request. His name is Somnath. SOMNATH. You can request him. He's a highly educated person. I told you he's BTech, MTech. Okay. So he understands the value of it. Okay. Group 15 elements react with hydrogen to form hydrides. Today you request hydrides of the type EH. I'm not writing intentionally M because all of them are not metal. E stands for element. Okay. From hydrides of the type EH3. So I'll write within bracket what is E. E is equal to nitrogen, phosphorus, arsenic, antimony, and bismuth. Okay. So let us write a name also. So I'll write it here. NH3 the name you know. See, I want that my all students should be very sincere towards study. Any problem, I'm there with you. I'll stand by you. But you have to tell me your problem, then only I can help. NH3 ammonia, all of us know. Rest of the thing, I don't know whether you know it. Okay. pH3, see, these are all common names. Yeah. pH3 is called phosphine. Yeah. So because of that, there is no similarity. ASH3 is called RC. SBH3, from here, see, these are very old. Because of that, people have given a name. And from here, the IUPAC name is there. See, CH4 is called methane, and this is called stibane. Okay. And BiH3 is called bismuthane. So you should know the name. So everybody should say that you people know chemistry. Then I will be very proud. It's not that I'm not proud of you, but I'll be more proud. But my question is that whenever I ask you anything, whether you, if you don't know, you say we don't know. If you know, immediately. Nah. আমি এদিকে তো গরম হয়নি মিটিং চলেন না তা so this is called bismuth. All right, so let us see all the compound that people have made it, are they stable? Huh? We have to check. So how to know the stability of the compound? The stability of the compound depends upon when you heat them. Suppose if you want to see whether a person is cool or not, so how to measure? Will you measure him by taking a thermometer? No, never. You try to irritate him. If you irritate him and if he gets angry, then you will not say he is cool. So similarly here, we want to know the stability of the molecule, we heat them. Okay, and if they decompose, then we call it, it is thermally not stable. Others will call it thermally stable. So let us see the property. So I'll write now. Okay. Thermal. So when the molecule will break, decompose, if the bonds are very long, dear. See, we know bond dissociation enthalpy is inversely proportional to bond length. When the bond length become, see, when you go down the group, size of the atom increases. As the size of the atom increases, the bond length increases. When the bond length increases, you require lesser amount of heat to break it. So in that case, what we can say, the thermal stability of the group 15 hydrides decreases down the group. So let me write now. The thermal stability of group 15 hydrides decreases down the group. Why? Due to increase in EH. See, E is the element. Bond length. Due to increase in EH bond length. So this is for your understanding. That what we'll write now here, bond dissociation. You need not by heart. I told you no question of by heart in science. Bond dissociation enthalpy is inversely proportional to bond length. So this is your knowledge. So what we'll write now? In short, thus thermal stability, smallest bond length will be the nitrogen. So nitrogen, if you heat it, it doesn't generally break. What we'll write now? So this is the
Done, sir.
Okay. Then B will go for solubility. Ability. Solubility means what? Solubility in water. I write. In water. You should never have any confusion. See, when a substance will be soluble in water, that you know it very well, when the substance will form hydrogen bonding with water. And we know hydrogen bonding depends upon the electronegativity of the central atom. This nitrogen is highly electronegative, so ammonia can form. Ammonia, nitrogen hydrogen bond is highly polar. Because of that, ammonia exhibit hydrogen bonding. But if you go down the group, see here, you know, if you go to this is like this. If you go down the group, electronegativity decreases, polarity of the bond decreases, hydrogen bonding effect decreases. So what should I write here? We'll write here now. The solubility, this is not given in your book, but anyway, you should know it. The solubility of group 15 hydride in water decreases down the group. But why? Due to I'm also getting mad. Due to decrease in the electronegativity of central atom E. We'll write ammonia is highly soluble due to its ability to form intermolecular hydrogen bonding. Acha, highly soluble in water. Why? Others are not that soluble. Okay. So what should I write now here? Again, I'll write summary. Summary is essential for your multiple choice question. We'll write now ammonia. I'll write like this. Highly soluble, more like this.
Done, sir.
Answer.
Very good, very good. So much of strength I require. I think I should go to gym to rub the board. Then comes basicity. Basicity. See, group 15 elements are Lewis bases. Sorry, group 15 hydrides. Group 15 hydrides. So I write like this: E H3 are Lewis base. Do you know what is a Lewis base? Huh? Hello. So again, you have
No,
gone for
sir.
this. Lewis bases means the compounds which has lone pair. If any of the element in the compound having a lone pair, they can donate a pair of electrons. So what is a Lewis base? A molecule which can donate a pair of electrons are called Lewis bases. And which are Lewis acids? The substances which can accept a pair of electron are called Lewis acids. See here. It can donate a pair of electron. Say suppose you have taken here acid H plus and you have taken say this nitrogen. Okay. I will write like this. E. See, it does not have electron, it can give electron. So what is going to happen now? What you will get now here? See, one of the electron of this element has gone to this Havana, is just lost this one. Just like that, your father is having money in your pocket, mother is having money in her purse, but your pocket is empty. So where from the money comes? Where from the money comes? From bank or from your parents? Huh?
Parents, sir.
So they are the donor and you are the acceptor. So acceptors are acids and donors are bases. Okay. So this is the one. So yes, all of them, ammonia, phosphine, see nitrogen have a lone pair, phosphorus is a lone pair, arsenic has a lone pair, antimony has, bismuth. So all of them are Lewis bases. Okay. But now you see the basicity of the hydrides decreases. This is a very important question for your exam. Basicity of the hydrides decreases down the groove. Well, due to the increase in their size. See, don't write, try to understand. See, this is nitrogen. It is having lone pair in its S2p orbital, hybridized orbital. Phosphine, it is 3p. Phosphine is larger than 2p. Arsenic, 3p. This. Antimony is here, the orbital is this. And bismuth, see, look, all of them have the same number of electrons. Look at the sizes. As the sizes of the orbital increases, is it not that density is decreasing? Huh? Density is decreasing or not? Say, you have kept a 5 rupees coin in your pocket of your shirt, and you have kept it in your pocket of your pant, and you have kept it in a bag which your father uses for marketing. Where can you locate it very fast? Where can you locate it very fast?
Pocket of shirt, sir.
Yes, that is, volume is less, so density is more. So as the sizes of the orbital increases, the density of the electron decreases. As the density of the electron decreases, donations become slower and slower. Okay, so what should we write now here? We'll write the reason now. Due to decrease in their sizes, because with increase in their sizes, density of electron decreases. This is the reason. This is important for your exam. So we'll write the summary. Always write the summary. Yeah? Any chapter, physics also you read, chemistry also you read, biology also, write the summary by yourself. In summary, only you have to write few points. And you see in exam, before exam, you can, if you are not able to revise the whole chapter, you can revise the summary. You will remember everything. I have learned chemistry in this way. I did not have any tutor. Basicity. Ammonia, here we are going to put lone pair more. Phosphine, arsine, antimony, and always write summary. So you write basicity, you write the order. Below that you write density of electron decreases. Finish. Then in exam, because in CBSE or MMBOS also, you don't have to write full paragraph. You have to write the answer in only 1 or 2 lines. You follow me. Even if you try also, you will not get below 80 in chemistry. You think, no, I will not read, I will go and appear. Because as you have all the summaries are in your brain, you will be able to answer each and every question. Even for physical chemistry that I have taught five chapters, write the summary. Okay. Say, I've already told you that I have heated thermal stability. No, we have found this is least stable. I heat it. What do I get? I get Bismuth and 3 hydrogen atoms. Why did I put it in bracket? Because we know hydrogen atom is not stable. So it's an atomic state. Atomic state, atomic hydrogens are also called nascent hydrogen. As it is not stable, so it has to combine. It either has to combine with itself or it has to combine with others. If it combines with others, addition of hydrogen is called what? Addition of hydrogen is called reduction. Okay? So which one will give hydrogen fast? Which one? Thermal stability you have seen now. We have found this is less stable. So it will supply hydrogen very, very fast. So this will be the strongest reducing agent, followed by this, then this, then this. And ammonia is so stable, generally does not give hydrogen. So ammonia is not at all a reducing. So now we'll write here now reducing capacity. Make it a point to remember. Forget the habit of reading science with the intention of by hearting that you have done in 9 and 10. Because of that, you could not understand it. Go by the logic. Logic will always support. So what I will write now? Reducing capacity of group 15 hydrides increases down the group. Why? Because you can get hydrogen only when it is unstable. When it will break down, so what will write now? Increases down the group due to decrease in their thermal stability or decrease in their bond dissociation enthalpy. When the bond dissociate, then only it will form the element and the hydrogen atom. All right. So therefore, what? To garam basa. Reducing capacity will be what? Ammonia will be less than phosphine, then arsine, then stibane, and bismuth. In fact, ammonia is not a reducing agent. Okay. In fact, ammonia is not a reducing agent.
Done, sir.
Then now we'll go for a very interesting one. Melting and boiling. Melting and boiling point. See, melting point of a substance depends upon how closely they are packed. And boiling point of the substance depends upon the intramolecular forces of attraction. If the intramolecular force of attraction is strong, in that case, you will find the boiling point will be more. And intermolecular force of attraction depends upon their sizes. If the size increases, surface area increases. If the surface increases, attraction increases. Okay, so I'll write now here. The melting and boiling point of group 15 hydrides increases down the group due to increase in their intermolecular forces of attraction. Why? Increase the forces of attraction. Why does it increase down the group? Because of increase in their intermolecular forces of attraction, which depend on their sizes. So you know, sizes increases down the group. See, here hydrogen size is same for all. Sizes increase down the group due to increase in the sizes of central atom. What is the central atom? Is the nitrogen, phosphorus, arsenic, and so in that case, what do you find? Bismuth should have the highest boiling point and melting point, and ammonia should have the least. But it is very strange. We found that ammonia has the highest boiling point and highest melting point. Why? Because of strong intermolecular hydrogen bonding. Intermolecular hydrogen bonding is a stronger force than intermolecular forces of attraction. We'll write now. However, ammonia has the highest melting and boiling point as they are closely associated with each other through strong intermolecular hydrogen bonding.
Done, sir.
Okay. So we have learned so many things now. Now we'll see the bonding media. বাবু পাশে ইয়ে করি বাইরের টামতে জল দিছি Okay, I'll write now. One.
6:30টার সময় মিটিং আছে তুই তাড়াতাড়ি কর
Ammonia. I'll write the bonding inside, huh? Hundred and 6.5. I know right like this. I want that include under no. This is the one, huh? 106.5. Excuse me for my bad handwriting. phosphine 93.5. Then arsine 91.5. Then thebaine 91.3 and bismuthane is 90.0. See, it is very strange. Say it is a small, this one nitrogen, you think it is small. Okay. So the say if this is the hydrogen, this is the hydrogen, and this is the hydrogen. And if it is 106, don't write 6.5. See, in that case, the phosphorus is bigger. So the distance should have been more. Bismuth is very big. See here. In this case, it should have been more than 106.5. But why it is so? So for that, let us try to understand. This it takes little time to understand, but I know you are mature enough to understand. See, try to remember your class 11 days. We have read about the VSEPR, valence shell electron pair repulsion. In that case, we have found the bond angle depends upon what? It depends upon the repulsion between different types of electron. Bond pair, see, this is lone pair, and this is called bond pair. See, all the electrons, whether they are paired or unpaired, they carry negative charge. So repulsion between lone pair and lone pair is highest. Right? See, lone pair electron does not have any control. But here in a bond pair, see, these electrons are being governed by two guardians, this and this. So in that case, you will find the electrons are not in one place. It is become spreaded. It spreads. So the density of electron here and here is less, but in case of lone pair, it is like this. So it is more. We found that repulsion between lone pair and bond pair is next to this, and minimum is bond. Okay. Now see here. In case of ammonia, why it is more? Because we know nitrogen is highly electronegative. So the electron has come here. After the formation of bond, electron has come here. Look, if when the electrons were here, they are far. When the electrons are nearer, repulsion is more. In that case, lone pair bond pair repulsion is more, which oppose. See here, bond, sorry, forget, here we do not have lone pair, so forget. So here, bond pair repulsion, bond pair repulsion is more. So it, in that case, just to avoid the repulsion, see, if this is like this, bond pair repulsion, because they are here now. So repulsion is more. To avoid repulsion, what happens? It moves away from each other. When it moves away from each other, then this angle becomes more. But when you go down the group, the electronegativity of the element increases. Sorry, decreases. So now when let us go to the extreme one. See here, let me take Bismuth. Bismuth is metallic, dear. Metals are least electronegative. So which is more electronegative? Hydrogen. See now, distance is more. In this case, as the distance is more, repulsion is minimum. So, as the repulsion is minimum, who will push? This lone pair repulsion will be maximum. So it will push them inside and make it 90 degrees. So we'll write it. Right. The H E H. See here. H E is for all elements. H E H. Bond angle decreases down the group in case of group 15 hydrides. Let me put some more here. Now why? Going down the group, electronegativity of central atom E decreases, and as a result, the bond pair drifts away from the central atom, reducing the bond pair repulsion.
বলতাগুলো আবার করে এসছে।
Thus,
ও, আমরা
lone pair bond pair repulsion increases, by which the bond angle of HEH get squeezed. What is the spelling of squeeze? S-Q-U-E double Z or what? Double Z. Yes. This is also important for your exam. ওই যে ইন্টারভিউ দিলে এটা আমাদের কত রাউন্ড জানো না?
Done, sir.
So with hydrogen now we have finished. We'll go to oxygen. Okay, so now we'll write B. Reactivity towards oxygen. The elements of this group form two types of oxides. Anything which reacts with oxygen, we call it oxide. Types of oxides. E2O3 and E2O5. E is equal to N P S S B and bismuth.
Laptop को दूसरे में देंगे।
Okay. The stability of +5 oxidation state. See, this is +5. Oxidation state, oxides decreases down the group. Why should they decrease? Because of inert pair effect, I told you. Because of inert pair effect. Example, Bi2O5 is not stable. All right. Second, we know that oxide should be basic, and oxides of metals are basic, and oxides of non-metals are acidic. So what should I write now here? The acidity of oxides decreases down the. I don't know that is given in your book, but everything I'm writing for your entrance exam. Decreases down the group due to decrease in their non-metallic character, or I can write increase in metallic. See, I write down here. N2O3. Okay, I write here. Oxides of. Here I'll write nitrogen. I'll write here phosphorus, acetic. I'll write now here hide. Arsenic, weakly acidic. Antimony, there is amphoteric. Amphoteric means which both act as a acid or base, acid and base. And Bismuth is basic. So these are all these points. I'll put bullet. Okay, now see here. The excuse me. Hello. Good evening, ma'am. हाँ जी. अच्छा, ठीक है, ठीक. हाँ. वो मैं अभी पढ़ा रहा हूँ दीदी. आप मैं आपको बाद में फोन करूँगा, ठीक है? मेरा क्लास चल रहा है. हाँ. अच्छा, now the higher oxidation state oxides are more acidic. Again, this is for your entrance exam. You should know. Means what? See here. N2O3 is less acidic than N2O5. P4O6 is less acidic than P4O10 because we know these are acidic. So you should know. Okay. Now we'll write the nitrogen form largest number of oxides due to their small size and ability to form p-pi p-pi bonds. P-pi p-pi bonds means where a pi orbital is being formed by the overlap of p orbitals. That day I have already given you, but still I am giving you N2O plus 1 oxidation state. ANO, this is nitrous oxide, this is nitric oxide. I have already given you the name. See from there, plus 2. N2O3, dinitrogen trioxide, 3. NO2 and N2O4 plus 4. This is called nitrogen dioxide. This is called dinitrogen tetroxide. And N2O1, dinitrogen pentoxide. This is plus.
Done, sir.
Very good. Okay. So now we'll write reactivity with halogens. You read the book, suppose if you feel that some portion I have missed out, tell me. Because I'm teaching you just from my memory. Then see. Reactivity towards halogen. All these elements react with halogens to form halides of the type EX3 and EX5. So what is E here? E, you know, it is nitrogen, phosphorus, arsenic, antimony, and bismuth. Okay. So now just like that, I'll write here the stability of +5. Okay, I'll write higher oxidation. Higher oxidation state. What is that? +5 decreases down the group due to inert pair for example BiX5. This is bismuth pentahalite. Are unstable except BiF5. Please remember, is an exception entrance. Except BiF5. Second.
Excuse me, sir.
Yes.
What you wrote after inert?
Inert pair.
Okay, sir. Thank you.
Inert pair effect. Bismuth pentachloride, pentabromide, pentaiodide do not form inert pair effect. Why bismuth pentafluoride forms? Because fluorine is a very strong electronegative element. It robs and pulls the electron of bismuth. Bismuth cannot resist. Okay. Now a very important point. Nitrogen does not form pentahalide. It is NX5 due to the absence of d orbitals. I'll show you now. I'll draw it for you. See nitrogen. Okay, this one nitrogen. See, this is 2s, and this is 2px, 2py, 2pz. Sorry, see here. It has only 3 unpaired electron. It doesn't have d orbital. So this 2 lone pair does not react. This is very important question for your both for your CBSE and MBOS and ICS. Okay, so no d orbital. So it only 3 unpaired electron yes. So nitrogen will show you NCl3, NF3 like that. It does not form NCl5 and N5. It cannot.
Done, sir.
Okay. So now, see this thing will read separately. Yeah. Reactivity towards metals. The elements of this group combine with highly electropositive metals. Okay. Example, say it is Li3N. We call it lithium nitride. Similarly is Ca3N2. This is called calcium nitride. This is group 1, group 2, aluminium. Aln 3. Valence of aluminum is 3. This is also 3. So this is called aluminium nitride. Say this is Zn3p2. Is called zinc phosphide. Why given zinc phosphide? Because you should know zinc phosphide. Most of the phosphates are a very strong poison, and zinc phosphide is used to kill rats. Rat poison is there, na? This zinc phosphide is extremely dangerous for human beings, highly toxic and poisonous for human beings. So you can have also calcium phosphide. So it's called calcium phosphide. Na3As. This is called sodium arsenide. Zn3Sb2 is called zinc antimonide. Okay. Mg3Bi2. This is called magnesium bismuthide. Oh, right. All right. Then so up to this much is enough. Then because I going part by part, so after that we'll enter into the main group with starting with different compounds. Okay. Then bye for today. Good night.
Bye, sir.
Thank you, sir. Good night.